Hello everybody, today we're going to be looking at an example of all these trig identities that we've been proving. So we have the question, we want to find all solutions to cosine of x over 2 equals sine of x. I see this x over 2, this immediately reminds me of half angle formula, and let's write that down. Cosine of x over 2 will be plus or minus the square root of 1 plus cos x over 2. And we wish for this to be equal to sine of x. I see the square root, I will square both sides, and I can get rid of my plus or minus this way too. Now, we have to be careful of checking the signs later on because there was a plus or minus here. So we'll deal with that later. Over 2 equals sine squared of x. I realize that here we have cosine x, this is sine squared. If I turn sine squared into cosine squared, this will be a nice quadratic equation to solve. So let's do that. 1 plus cosine x over 2. Sine squared is equal to 1 minus cosine squared x. And multiply both sides by 2. 1 plus cosine x is 2 minus 2 cosine squared x. Move everything to the same side. 2 cosine squared x plus cosine x, and 1 minus 2 minus 1 will be equal to 0. I can factor this as we would a quadratic. So we have 2 cosine x, this is 0. I see I need a plus cosine x here, so this is going to be plus 1 minus 1. Okay, so from the first factor, we have that 2 cosine x minus 1 should be equal to 0. Solving for cosine x, we get that cosine x is equal to 1/2. There's two angles for x that will give me 1/2, which are when x is equal to either pi over 3 or 5 pi over 3. Now, since we wanted all solutions, we might be tempted to say that this was plus 2 pi n and plus 2 pi n to both of these. But we have to be a little bit careful with that, because remember, this was cosine of x over 2. So, now if I have cosine of pi over 3 over 2, and I added 2 pi to this thing, this should be equal to sine of pi over 3 plus 2 pi. If we calculate this out, well, this will be cosine of pi over 3 over 2. This is pi over 6 plus 2 pi over 2, which is pi. So in total, we have 7 pi over 6. And we wish for this to be equal to sine of 7 pi over 3. This right here will be equal to negative root 3 over 2. However, sine of 7 pi over 3 is positive root 3 over 2. And remember, back when we squared both sides of the equation, we got rid of the plus or minus, and this is where the issue came in. We can't simply add 2 pi n to x, because in reality, I'm only adding pi to this entire equation. So what we should do is we want cosine of x over 2 plus 2 pi n. But this 2 pi n, I can't just add it to the entire x over 2. I need to add it to x. So I can rewrite this as cosine of x plus 4 pi over n over 2. Only by adding 4 pi to x will I be able to add 2 pi to this entire expression. So we can adjust both of our answers by adding 4 pi n instead of 2 pi n. So x is pi over 3 plus 4 pi n. X equals to 5 pi over 3 plus 4 pi n. We still have one more over here, so cosine of x plus 1 is equal to 0. Cosine of x is equal to negative 1. Cosine of x will be equal to negative 1 when x is equal to pi. Now, we're not quite sure if we can add 2 pi into this, so let's check. cosine of pi plus 2 pi over 2, if I added 2 pi to x, should be equal to sine of pi plus 2 pi. Evaluating this, we get that cosine of 3 pi over 2 is equal to sine of 3 pi. This will be 0. Sine will also be 0. And we're okay with this. In this case, there weren't any issues because cosine came out to be 0. And before, we got that one was a negative version, one was a positive version. But since both sides are 0, it does not matter. So here we can safely put plus 2 pi n as our solution. So in general, we have this solution and these two solutions. Be very careful to check whether or not you can actually add 2 pi n to your answer when your equation contains an x over 2 or an x over 3, x over 4, whatever denominator you might have. I'm going to also provide an alternate solution to this problem that takes care of the fact of how we have to check for our solutions. So since x over 2 was the thing we had to be careful about, well, let's just try to turn everything in terms of x over 2. So we'll have cosine of x over 2 is equal to sine of 2 times x over 2. This side, well, I can apply the double angle formula. So cosine of x over 2 will be equal to 2 sine of x over 2 cosine of x over 2. This x over 2 is kind of making me uncomfortable, so I'm going to let y equal x over 2. Cosine y equals 2 sine y cosine y. So we be careful because we do not divide by cosine y. This will make us lose the solution of cosine y equals 0. The proper way to do this, move everything to the right side, equals 2 sine y cosine y minus cosine y. Now I can factor out the cosine y equals cosine y times the quantity, 2 sine y minus 1. Now from here, we get that either cosine y equals 0 or 2 sine y minus 1 is equal to 0. Okay, now cosine y will be 0 when we either have up here or over here. So we want y to either be pi over 2 plus pi n. Right? I can go up here, I can add 180, add another 180, add another 180, so that's why this is plus pi n. We were interested in x over 2, however, so I substitute that x over 2 equals pi over 2 plus pi n. I want x equals pi plus 2 pi n, which is what we ended up with earlier. Solving this equation, I get that sine of y is equal to 1/2. So we know that y must either be pi over 6 plus 2 pi n or 5 pi over 6 plus 2 pi n. Again, I'm interested in x over, so I will double each of these equations, or each of these solutions. I get that x is equal to pi over 6 times 2 is pi over 3 plus 4 pi n, or 5 pi over 3 plus 4 pi n. And here again are our solutions that we got from before. I would recommend doing it this way. It's harder to mess up on your work. The other way, you must double check to see if you can add 2 pi n to your answer.